Let's do some examples of infinite limits. Let's see, in this case we have x approaching 2 from the low side, so x is always 2 minus a bit. What's going to happen? We can look at the top. The top, if x is approaching 2, then that's going to get closer and closer to 2. And this is going to get closer and closer to the sine of 2. Now the sine of 2, I know that as long as the angle is between 0 and pi is a little more than 3, as long as the angle is between 0 and pi, then the sine is a positive number because you'll be moving up to that point on the unit circle. So this is going to be positive, that's positive. Now down here we have a number, if the number is actually less than 2 by a little bit, when you square it, this will be less than 4. Minus 4 will be negative. But the closer x gets to 2, the closer this will be to 4. So we're going to be dividing by tinier and tinier negatives. We know that the top is positive, so if positive divided by negative, it's going to have to be negative. And if we have a positive number and we divide by tinier and tinier numbers, then we're going to get infinity. So this limit is negative infinity as x approaches 2 from the low side, from the left. On the other hand, if x approaches 2 from the high side, again the top is getting closer to 2 sine 2. And the bottom, if x is a little more than 2, if you have a little more than 2 and you square it, that's a little more than 4. A little more than 4, take away 4 would be positive. But the closer x gets to 2, the smaller x squared minus 4 will be. The closer x squared and 4 will be, right? So the smaller that will be. So we're dividing by tinier and tinier positives. So a positive divided by positive will definitely be positive. And then if we have a regular size number, and this is approaching some positive number here, and we divide by smaller and smaller numbers, they'll go in there more and more times, and so we'll get infinity. In this case, the left and right limits don't match. So if we were asked just about the limit as x tends to 2 of x sine x over x squared minus 4, we would say that doesn't exist, not even as an infinite limit. It does tell us something, though, about the behavior of the graph of this function near 2. You can see that if we're interested in what happens near 2, where this function is undefined, as x goes to 2 from below, so as we come closer to 2 from the left, the function is going to go down to negative infinity. And then as x goes to 2 from above, so as x approaches 2 but is always 2 plus a bit, that's going to go up to positive infinity. So we do know at least that much of the function, that it's got a vertical asymptote with this splitting behavior as x tends to 2, and we got it by considering the left and right hand limits. Let's do another one. Let's see, we're going to have the limit as x tends to 0 from below of x to the 3/7 minus 5. So what's happening here is we have a tiny negative number raised to the 3/7 power down here, and then we're subtracting 5. So, all right, well, if you take, this means cube it and take the 7th root. So if you have this tiny negative, we take the 7th root, and it's still fairly small, and then since it's an odd root, like a 7th root, then it still remains negative. Then we take that negative number, that number that's a small negative, and cube it, and it becomes a smaller but negative number. So we have 1 over tinier and tinier negatives minus 5. So as we take this 1 and we divide it by tinier and tinier negative numbers, then this is going to go to negative infinity, because a positive divided by negative has to be negative, and tinier and tinier numbers will go into 1 more and more times. So we have negative infinity minus 5. So we'll just say that's negative infinity. So you can, basically what we're saying is that the closer x gets to 0 from the left-hand side, right? The closer x sneaks up to 0, then this number becomes just more and more negative. Combine that with this negative 5, and you're just going to get more and more negative. That's what the negative infinity indicates. Okay. In this case, though, our number is x is going to 0 from above, so our number is positive. So we have tiny positive numbers. Now you take a tiny positive number and take its 7th root. It's still somewhat small. You cube it, and it becomes a little bit smaller than it was. So we basically have 1, and then subtract 5. Then we have 1 divided by tinier and tinier positive numbers. So we're going to have a positive divided by positive will be positive, and these are just going to get bigger and bigger. So big, in fact, that they will definitely overwhelm this negative 5. Right? We'll go right past 5 and keep on going, and so there's no limit to how high we can get out of this function. So again, if we were asked about the limit as x tends to 0 without regard to which side, we would say that doesn't exist. Not even as an infinite limit. If we alter this problem just slightly, I change the exponent from 3 to 2, so now it's an even exponent. Now what happens as x tends to 0, even if x is negative, you can think about x to the 2/7 as being x squared and then take the 7th root. So we're really talking about the limit as x tends to 0 from below of those. Now, as x goes to 0, even though x is a negative number, x squared will be positive, and the 7th root of a positive has to be positive. So we have 1 divided by, we'll say, tinier and tinier positives, minus 5. Well, it doesn't really matter. 1 divided by tinier positive is going to get bigger and bigger, big enough to overwhelm this negative 5 and keep on going. So this limit will be infinity. Same thing if you take the limit as x tends to 0 from above, and because again, if x is 0, so x squared is x is bigger than 0, so x squared is certainly positive, and the 7th root of a positive is positive, so we have 1 over tinier and tinier positives minus 5. Again, this just gets bigger and bigger, goes right past 5 and continues on, completely overwhelms this negative 5 and gives us infinity. In this case, the two limits match, so we can talk about this limit. We could say this limit is infinity. So it doesn't exist as a finite limit because infinity isn't a number, but it does exist as an infinite limit, and it does give us information about this graph. It tells us for this function, whatever its graph looks like, as you start to get close to 0, whether you get close to 0 from the right or from the left, the outputs start to get bigger and bigger without bound. So in this case, you know that if you're close to 0, whether you're on the left hand or the right hand of 0, you'll be getting numbers that are very big. So and the closer you get to 0, the bigger they will get.